Hello, now we're continuing our work in patterns, and today we're looking at arithmetic or linear series. Now a series is just a name for where we're adding up the terms in our list instead of just listing them out with commas in between. So it's when we're adding up terms is when we have a series. So if we had our list of terms here, 1 plus 4 plus 7, what's the pattern between them? We're adding on 3 each time. So we still have a linear pattern because our difference between the terms is still plus 3. We're still adding on the same amount each time, so we have the same common difference each time. So we've got a linear pattern, but we're adding up the terms, and if we add up the first 3 terms in our list, we get 12. So 1 plus 4 plus 7 ends up being equal to 12. And writing that out more abstractly, term 1 plus term 2 plus term 3 added together is called the sum of the sum 3, or the third term in our sum. So the formula for this, like our terms formula, comes from page 22 in our log tables, and if we recognize we've got a series, again we're immediately opening up page 22 in our log tables so that we see what tools are available to us. And our formula is here. It's a little bit more complicated than our term formula, but it's perfectly manageable. One of the things that is important about the terms, just like with the terms formula, we knew that at tn minus 1 always gave us the difference between our terms. If we get s of n minus 1, that is going to give us the nth term. And to put that in more concrete terms, if we had the sum of the first 3 terms and we took away the sum of the first 2 terms, we must end up with the third term in our pattern. Why? Well, if I write out s of 3, I have term 3 plus term 2 plus term 1, and I'm taking away term 1 plus term 2. So these all sum to 0, and I'm just left with term 3. So this is very important for more advanced questions, in the same way as our tn minus 1 is equal to d was very important for our more advanced term type questions, our more advanced sequence type questions. So this is going to be important for some of our questions later on, but this is the basic formula that we're going to be using all the time. So let's put it into practice. If I have a series like 3 plus 7 plus 11, I recognize that I have a linear series here because I'm adding on plus 4 each time. I'm adding on plus 4 each time, so I know I have a linear or an arithmetic series. Both terms are used, so we need to know both. So this is an arithmetic series. That means that I am immediately going to page 22 in my log tables and writing down this formula. And in this case, I am asked for the sum of the first 10 terms. So I'm asked for s of 10. So what am I going to do? I'm going to find out. I'm going to write down my formula. Now that I know I have a linear pattern or an arithmetic pattern, because I can see the difference between each term is the same, I'm going to write down that pattern and then see what I'm able to sub into it. So what do I need? I know that n is eventually going to be 10. I'm going to find s of n first, because for lots of questions you're going to want to do that. In this question, you could actually just sub in n is equal to 10 immediately while you're subbing in a and d. But in an exam style question, you're almost always going to need s of n for something more advanced. So that's the way I'm going to do it. So we're going to find s of n first, and then we're going to find s of 10. So I need a and d. Well, a and d mean the same thing as they already did for my tn formula. A is my first term, which is 3, and d is my difference between my terms, which I've already figured out is plus 4. So subbing in then, S of n over 2 on 2 by 3 plus n minus 1 on 4. N over 2 on 6 plus 4n minus 4 is equal to n over 2 on 4n plus 2. Multiplying in, I end up with 2n squared plus n. Multiply what's outside the bracket by each thing inside. So this is my S of n. So I'm asked for S of 10 in the question, and I've done it this way because in an exam you're likely to need S of n for other parts of the questions. Here we could have subbed in n is 10 immediately. S of 10 is going to be equal to 2 on 10 squared plus, sorry, that should say n. My apologies. Multiply each of those in and you'll end up with 2n squared plus n plus 10. So I end up with 200 plus 10 is equal to 210 is my S of 10. So that is one style of question that I could ask. That's the most basic form of question that they could ask me. Another style could be if I was given S of n, and I was asked to use it to find the terms. So I've been given an equation for the sum of the terms in a series. If I'm asked for the equation of a particular term, how could I get it? Well, I know that if I have S of n and I subtract away S of n minus 1, if I subtract away the last sum term, I must be left with Tn. So let's try that out. If I have S of n minus S of n minus 1, that must be equal to Tn for the reason that I showed you over here. So I want to write down what S of n minus 1 is. So S of n is 3n squared plus 1. I'm given that in the question. And then minus 3 on n minus 1 to be squared plus n minus 1. Anywhere there was an n in my original formula, I now have written n minus 1. And I need to square out my brackets. Square the first by the second and double it. Square the second. And I end up with 3n squared plus, sorry, I should have an equals in between each of these lines. Plus n minus 3n squared minus, sorry, should be a bracket there, minus 6n plus 3 plus n minus 1, 3n squared plus n minus 3n squared plus 6n minus 3 minus n plus 1. I can gather up my like terms now. So I have n squareds here. I have n's here. And I have pure numbers here. So that sums to 0, and I'm left with 6n minus 2. So that it would be my nth term, and I get it by subtracting my nth series term away from my n minus 1th series term. So that is another style of question that we can deal with. And it's again based on the fact that if we subtract our nth up to the sum of our up to our nth term away from the sum up to our n-1th term, we must get the general term. We must get it Tn for the series. And that is what we need for now.